Alright, we're going to do the stream a little bit earlier this week. I just won't be able to do it tomorrow, so I'm going to do it now. Last time we were working on retraction settings. We were following Teaching Tech's guide. You know, he has kind of a, on GitHub, he has a guide of do this step, then this step, and this step, and some of the steps he has G-code generators, and it's really well done. And we were on the one for retraction. So we had printed a retraction test here. I think I've already cleaned it up, but we had printed one, and this one was to try and determine the right retraction amount, and it was all very similar. None of them looked crazily different from the others, but it kind of looked like 6 millimeters was probably our better one. So then I printed another one. It's still on the printer right now, but it is for what speed, and honestly they all look the same. I'll show you what it looks like. It just finished printing. Actually, you can't see it there, can you? So it's right there. I don't think you can see any real difference at all on it. I don't even know if you can pick up the strings on it. Yeah, you can. I can see them on the camera, so I think you probably can too. There they are. None of them look any different than the others. So what I'm going to do, this one was, they had different speeds, all set at 6 millimeters of retraction. So I'm just going to go with the slowest speed, because if I can do the slowest speed and it works, then that should be fine. I don't see nothing on this makes me think that one of the higher speeds is going to be a problem. So let's go and see what the slowest speed I had set was. Let's see. 35, it's right here, 35, that's millimeters per second. So I'm going to do 6 millimeters of retraction, which is kind of in the middle of a Bowden tube Ender 3 style printer. 5 to 8 is usually where you're at, so 6 is somewhere on the lower end. And then 35 is kind of in the middle of speeds. I did try some that were higher than what you normally would do, but they didn't seem to make any difference. So I'm going to go to Cura and put in 6 millimeters of retraction and 35 millimeters per second retraction speed. Alright, so let's look at our... Oh, yeah, we'll come back to this, the flow rate thing. Let's look at retraction right now. So, retraction distance, we're going to say is 6, speed 35. So we're upping the distance a little bit and dropping the speed some. Because the speed on this didn't seem to make any real difference. So that's what we're going to go with for the time being. Now these are also material dependent, so different materials will have different retraction settings if you get really particular about it. And this material that we've been using is PLA. Alright, so the things we're going to do today. Let's look back at this flow thing, because you'll notice from last time I had set these to 95%, because based on, we did our E-steps, and then we did a little flow calibration cube and measured all the walls were coming out several, well, tenths of millimeters, so not a lot, but several tenths of millimeters larger than they should be. And we calculated the flow rate was like 15-20% overflow, but I dropped it down to 95%, and I printed some new vases. You remember I showed you some new materials? Printed some new vases, and they printed okay, except that there are some pieces where the material wasn't joined together. It was under extruding. So I've since bumped the flow back up to 100%. It's going to about change anyway based on what we're about to do today, so I did put it back at 100%. Just that was that same note of trust your eyes when you're actually doing these things. You can calculate a lot of things to figure out a number, and then that number isn't taking into account all of the variables associated with it. So I did go back to 100% flow on here. Let's look at the things that I printed. So I printed, oh, we got to zoom out to see anything. Hold on a second. Our camera froze up on us, so we gotta reset it there. All right, now you should see the camera. So I printed this, well, maybe it's still not acting right. I may have to show you using another camera. I'll give it another shot and see if it's gonna behave or not. All right, now we're back doing stuff. All right, so I printed this. This was the PLA TPU blend, and it's the blue one. It printed really nice, except remember I had the flow rate at 95% on this, and see if I can find it. These parts, these are overhangs right in there, and you can kind of see how they're delaminating. So then there's several. There's another one. Same thing happened on the other part I printed at 95%. So the flow rate just didn't seem to be enough. So I've since gone back to 100%. But this is the PLA TPU mix, and it is kind of flexible, but not like regular TPU flexible. So it's not like that. I think I would not call it flexible. I would call it a little tougher. So it's able to deform a little bit before just snapping. Now these, I'm pretty sure if I apply, since they have such bad layer adhesion here, see, it's cracking. I can't do much, but it's because the layers are coming apart. They're just not welded together well enough. So that's a problem with that, but I think that's more flow rate, and I might have been printing a little bit on the cold side. So if you get this to happen, you know, your parts are just not holding together. Flow rate could be one issue, and too low of temperature. So it's able to extrude the filament, but it doesn't actually extrude enough of it. Or it's too cold and it's printing, but the layers are not bonding together very well. So either raise your temperature or your flow rate, or both, if you have this kind of cracking type of thing. The other one I printed was tritium green, and it's just a cool filament, I think. It's got some little sparkles in it. I don't know if you can see them on the camera or not, but it's got some, yeah, you can kind of see them there. Got some sparkles. It's a little bit see-through. It is not a PETg. It is a PLA, but it still is a little see-through, and it's a neat filament, but it's also got that same problem of under extrusion, probably because of my flow rate being too low. The next ones I'm going to print, I got a sample, I guess just yesterday maybe? Last week, I don't know what day it was. This stuff, it's PLA. Let's get the thing right side up. PLA, and it's from Flash Forge. And it's just a really nice color. It's called burnt titanium, and I want to print some of that to see what it looks like. It prints like normal PLA, so I don't think there's any special properties of it other than it just looks really cool. It's got kind of a purplish color shift mixed with teal. It's just really cool. I want to print some, see what it looks like. So that'll be the next vase we make, is this one. Today we're going to look at a new material. We're going to look at PETg. So I have a little sample of it, and this is just a recycled PETg, but let's look at what PET in general, why you might want to print with that. So let's go over here to the web, and let's look at our stuff. I've made this kind of reference sheet for PETg. So PETg, it stands for polyethylene terephthalate glycol modified. So there's the PET, and PET is its own material. So PET is a separate thing. Once you add the glycol to it, it changes its properties pretty significantly. So It is a thermoplastic. All of these have to be thermoplastics for FDM to print them. Thermoplastic means that you can heat it up and deform it, and it'll keep that new shape. Basically, it doesn't liquefy, is what it kind of means, versus a thermoset type of thing. It does have some benefits over PLA. For instance, it's not particularly more difficult to print than PLA, but it has a higher heat resistance. So the glass transition temperature of PLA is in the 60 to 65 Celsius range. PETg is closer to 80 Celsius. So that's a pretty significant bump in how hot PETg can get before it starts to deform. And it's a little bit easier to print than ABS. So ABS does have an even higher glass transition temperature, but ABS has some issues with warping. It smells bad. It usually has to be in an enclosure to print it. So it's just got some issues on printing with this kind of printer. ABS does. And so PETg is kind of right in the middle of those two. It doesn't smell bad when you print it. It prints relatively easily. It's got better glass transition temperature, so heat deformation. That's not the word I'm trying to think of. I'll think of it eventually. But glass transition temperature is better, and it's not as hard as ABS to print. It's usually clear. In our little sample here is another one that's got some transparency to it. It's pretty durable, and it's relatively flexible. Not like TPU flexible, but it's got some toughness to it, so it can deform without shattering. It's recycle code 7, so it's not in the PET 1 category. It's in code number 7, which is mixed and other. So it doesn't recycle the same way as PET would. In fact, the sample I have is recycled PETg, so it's 100%, or well, it doesn't say. But it has at least some amount of recycled PETg. I think I showed one last time that was 100% recycled. So here are some of the properties. Strength and durability. For this kind of printer, now there are certainly materials that can go beyond this, right? It's just that they can't easily be printed on our open air FDM bed slinger kind of printer. So you have to do some modifications or have a different level of printer to print these other materials that can outperform PETg. But it's similar to ABS in strength. It's relatively easy to print. It is a little bit stringy, so that's why we've been working on retraction settings some, is because we may have to even do some new retraction settings specifically for PETg. It's a little more flexible than PLA, like we already said, and I don't know if it's more flexible than ABS or not. It probably is slightly. ABS is relatively flexible though. It is chemically resistant in general. It is, now I'm going to say PETg, the bulk material, there are food grade levels of that, and it's food safe. Printing it is a different thing, because the printing process itself could create problems. So for instance, you're printing in layers, and those layers have tiny little ridges, and bacteria can get caught in those ridges. You're printing with a brass nozzle. Technically, you're pulling brass atoms out of the nozzle and putting them into your print. It's not a lot, but you are pulling some material from the nozzle, putting it into the print. So that could be a problem, particularly if you're pulling some of the lead that's in brass. I think brass is allowed to have some amount of lead. So I would not say that 3D printed materials at all are food safe. They might be food compatible, they might be okay, but you're going to have trouble cleaning them. I do have that, did I write it down? I don't think I wrote it down. But PETg is able to be sterilized, but the sterilization processes are stuff that typically you're not going to have at your house, right? So if you're in a lab setting, you might have access to low temp autoclaves and the hydrogen, I don't remember what it's called, but there's a hydrogen way to clean, and a couple of chemicals. You can sort of clean it, but not sterilize, but clean with isopropyl alcohol. So you can do that at home, but that doesn't count as like sterilized. It's just clean, and it kills most of the microorganisms, but not all of them. Like I said, it has better heat resistance than PLA, and the transparency. Sometimes you don't like that, but it is a property of most PETGs that it's by default translucent, and so you have to change additives to it if you want it to not be translucent, and so it makes a really nice print. Another one I should have written in here that I didn't, but I've just now thought of, is that it can be sanded and polished. So I don't know if let me see if I can find, oh, I see it. Let me go get it. So let's go to the big screen here. So this is an ocarina in PETG, and you can, and it's, you know, it's kind of translucent, not a whole lot, but a little bit. This has pretty thick walls, solid walls. That's another thing for another day, but in general, if you're doing musical instruments out of 3D printed material, you want the walls to be pretty much solid so that you get the right resonance type of things happening. So this is not as see-through, but you can see, you can polish it up pretty nice with plastic polish. So sanding and some plastic polish can make it pretty nice. Let's go back to what my other lists were here. Oh, I've got some of the applications for it. So the little clamshell cases, you know, the little clear stuff that food sandwiches come in or whatever, those are usually PETG. Sometimes it's the fact that it is translucent lets it be nice for vases and stuff where light is important. Like part of the feature is that it can transmit light through it. It is nice for prototyping, so because it's easy enough to print, but it has a little bit more I'll call it strength, but it's not like its tensile strength is stronger than all the other materials, but it just is a better material to prototype with when you can. The downside to it is that the stringing can be an issue in some cases. Speaking about printing it, it does print a little hotter. This one says it goes from 210 to 250, so we'll print it not at the 250 range, but on the lower end. Bed around 70 to 80. That's a little bit hotter than what you've been doing or what I've been doing with the PLA. A little bit slower, but it's not that slow. They've got 30 to 60. This one has actually this one doesn't say. Yeah, it doesn't say on here. But I'm probably going to print it around 50 or so millimeters per second. Cooling is an interesting thing. Now this recycled one, it says fan speed 100%. That's unusual for PETG. Normally PETG, you don't want a lot of cooling because it will do the same thing that our vase here did. No matter what your flow rate is or temperature is, it will delaminate because it doesn't adhere too well to the prior layers if you have a lot of part cooling on it. But if you have no part cooling, it gets really stringy. So you can get your part just doesn't have as nice a surface finish, and it's got strings everywhere. So I usually run PETG with 50% layer cooling. I don't know if I'll try this one with 100%, but I'd suspect it's going to have weak layers. But that's what it says on here, so I don't know. Retraction, it is stringy, so you probably are going to have to set up your retraction settings for PETG differently, a little more aggressively. Layer adhesion, when it's printed without 100% cooling, except maybe this stuff, it does have really good layer adhesion. That's why, you know, because it's staying gummy longer, which is also why it strings, and so it sticks together pretty well. But one downside is it can stick too well to your print surface. So it is generally good practice to print PETg on a surface that you have some glue stick on, or hairspray, something that'll act as a release agent. Because if you print it straight onto like plain glass, now this bed on here is not plain glass, it has a texture on it, like it's a little PEI dots on it or something. But if you print it straight on plain glass, there's a good chance that it will bond strong enough to that glass that in order to get the part off of the glass ends up breaking, or even chunks of the glass pull out. So if you do print PETg and you're printing on glass, then I would definitely put down some glue stick, or if you don't like the surface that glue stick does, then just do some hairspray. I usually use this stuff. Where's it at? I usually use this, the Purple Can Aquanet. It works pretty well. The Purple Can Aquanet also works when you're having trouble sticking stuff down. So it doesn't just work as a release agent, but it also works to help hold parts down if you're having trouble with it. Okay, so let's move away from PETg for a minute, because I've got a couple of upgrades that I'm going to look at. I don't know if you call them, they're changes. They are slight upgrades. Your printer might already have these things. My printer does not. So I'm going to upgrade my printer. But again, for yours it might be a downgrade or the same, no grade. One of them is, let's get this off of here. Wow, that was, oh, the bed's still on. So that warped. That's fine. All right. One of them is this. Let's get down there to it. This is a replacement feeder mechanism capstan for my feeder extruder. The difference on this one, well, one thing is this is all metal, but that's not the real reason I'm changing it out. There's two real reasons. One, for whatever reason, the one that's on here already, that came from factory, it's really hard to load filament into. Like, it's just hard to get it lined up. Normally that's not a problem, and I changed them for a different reason. But in this case, that's an annoyance enough that alone would be reason to change it. But the real reason I want to change it is these pieces. So let's see if you can, yeah, you can see from there, but let's see if we can get a little closer. So this piece is going to go onto the the stepper motor itself. And then this one, those gear teeth mesh together. So now what I have currently is the one on the stepper motor turns, and the other one's just kind of an idler. It's just a grooved pulley that is just kind of holding the filament there. In this case, both of these will turn because they're going to be geared together, and they'll grab the filament from both sides and push it in, or pull it out if it's retracting, into the print head. So that is a geared one. Now, some of these you'll see geared feeders that are they're using a gear ratio. This one, the ratio is 1-to-1, so I'm not getting any sort of mechanical advantage from the gears. It's just that both sides of the feeder will grab the filament and push it into the tube. So we're going to change that out. These, you can get them off of Amazon for $20-ish or so, I imagine. The other thing I'm going to do is, our bed down here has springs, like most of them do, which are not bad at all. But I am getting ready for this printer to have a bed sensor on it, so it can detect the shape of the bed and adjust for that. And not in order to do that, but as a extra feature on top of that, I'm going to change out the springs with solid rubber mounts. So I've got 4 of these little solid rubber mounts. These you can get off of Amazon for, I don't know, $5 maybe. Sometimes they come in kits that have other things also, so it costs more. But these are going to replace the springs. They are rubber, so they're springy a little bit, but not nearly as springy as the springs are. So what that'll do is it'll just remove a few sources of vibration in the bed. And since I'm going to be using a bed probe to probe the surface of the bed to detect where it's at and what shape it's in, then I don't have to worry quite as much about constantly having to adjust these things to get the print just right. It's actually printing really well right now, so these probably won't make much difference in the print quality. They're just this one. Oh, we locked up on the camera again. It seems like whenever I zoom in is the problem. The feeder will give me a quality of life improvement because it'll just be easier to feed the filament into. But the others, they probably won't make a whole bunch of difference. But I'm just showing you throughout the quarter, just showing you a lot of the different things that you might want to try at some point. Let's see if we can get our camera back working for us. I think whenever I zoom in a lot, it doesn't like it. So maybe I should stop zooming in, because every time I zoom in, that's when it locks up. Alright, I left the printer on because I need to remove the filament in order to change this feeder. So removing the filament, I'm just going to push it in a little bit and then pull it out. If you don't push it in and have it extrude a little bit, what will happen is there'll be a knot on the end of the filament and it's hard to pull through. So if you just push through and basically melt that knot, then it's easier to pull the filament out. Alrighty, now I can turn the printer off. That'll save a little sound too. It's a loud thing. Let's go around here. Alright, so one thing you do have to be aware of, and I really need to zoom in to show you this, but I don't want to. Maybe it'll show up when we get further into the removal here. But I need to replace that brass drive with this one. There are some printers, particularly some of the Ender 3s, that this brass piece is pressed onto the stepper shaft, and it is very difficult to remove. Unless you have, which I do have, I don't know where I can find it. I'll look and see if I can find it really quick, but unless you have a gear puller that fits that size, it's really hard to remove them. Now this one does not. This one is not pressed on. You can maybe make out that little black spot under my fingernail. That's a set screw, so I can just untighten those, loosen the set screws, and that brass part will come off. But if you don't have those set screws on there, it's going to be hard to remove that brass drive, and you have to remove it if you're replacing it with the geared one. So that can be a hold up on some of your printers. So before you go and buy one of these things and think you're going to easily install it, make sure that you don't have a pressed on drive wheel. All right, let's start disassembling. So we'll take those out of the way just to get them out of the way. I do like that this printer has the little tray you can keep all the stuff in. I like that. Let's see. It looks like we need this one. No? Oh, this one. Now, another thing, there's a very good chance if you're changing this out that, I'm not sure what's going on here, that you're going to have to modify your E-steps. So be prepared to do that. We did that maybe 2 meetings ago. I don't particularly like the tools that they gave here. Apparently they're not quite standard sizes. So I'm having trouble getting it to fit in here. There are 4 of these screws that are holding this all together. This one's the most annoying one because this spring is putting pressure on it. So that's what I'm doing here, is relieving some of that pressure. And it's in this corner where the Z-rod and the Z-axis rail are right in the way. So both of those things make it a little bit hard to get out. All right. I am going to save all the pieces here because I might want to put it back on at some point. Now I've got one that you can see here, and there's one on either other corner. These are a different size, of course. Do be aware that once you get the last one of these out, they are also what's holding the stepper motor in place, so it'll fall down. So be ready to catch it. Oh, that's too small. This is not one that I have to remove for removing the capstan, but it's in the way of the screw, so I got to take it out. This screw that I'm messing with right now is the one that you can tighten it to apply more pressure with this spring. If your filament is slipping and you think it's because it's too loose, then you can tighten that up. It's usually not the problem, but you can try it anyway and see. Wow, that's tight. This one, there it goes. Okay, so one more and the stepper is going to fall out of the way. That's why I'm trying to hold it. There we go. All right. So all of that. Sometimes I reuse these screws, but it looks like I have all the screws that came with the other one. So let's look at this guy. So there's those set screws there, and there's another one there. If those are not on these things, then it is going to be hard to get that brass piece off of there. And I've actually never gotten it off of there without a puller. There is one you can print on Thingiverse maybe, and I did print it, and it did like attach and try to pull it out, but it just broke. It was not strong enough at all to pull it off of there. Let me look and see if I have mine that actually will pull them off. Let's see, here's my one of my little printer toolboxes anyway. I don't know if I put it in here or not though. I don't see it. I'll look around for it and see if I can find it to show you that there is one. I got it off of Amazon. I might can find it on Amazon where I bought it because it does work. It doesn't have great reviews. But I think the poor reviews are a function of it's not that intuitive to use, and I could see that being the problem with it. Let's see. I can find it. Let's see. Here it is. All right, so it's this one. This one will work, but I don't remember even if it had instructions with it. Maybe it did, maybe it didn't. But I do remember it wasn't super intuitive on how to make it, you know, what combination of everything to do to actually get it to work. But it does work. It doesn't break. $11, get a 5% coupon apparently. And it did work to pull those things off of there without breaking itself. Every other thing that I tried either was tearing up the tool or tearing up something on the stepper motor, and it just wasn't working. So this one does work if you end up needing to pull those little brass things off of there. Fortunately, this one, it's just easy to get off, so that's no big deal. All right, now let's start reassembling our new one. So it's gonna go here. I believe this is one I've used before because it looks worn, and I probably removed it. Oh, I know why I removed it. I removed it to go to a direct drive, so a totally different setup. All right, kind of want to make sure that your wires are not in the way somewhere, so it doesn't matter what orientation you use, you just want the wires to kind of be out of the way. So I'm gonna do this way with them. Let's put this one in first because it's going to get covered up anyway, and I need something to help hold things in place here. It's a good idea to not tighten anything down until you've got everything started in general. Let's see if we can find the right sizes for things. That one's too big. Also, don't put this screw in until you've got the one that it covers up in, because that can be annoying. Okay, so I've got all of those started. I'm going to go ahead and tighten these three down. I know I didn't start this one yet, but I'm going to tighten these and hope that 3 out of 4 are enough to line it up. I didn't check. We might have an issue where this fitting may not fit in here, and it does not. So that'll create a little bit of an issue. I have several other of these, and when you get a new one of these, they come with the fitting that goes there. I'll have to find one for that will fit in there in my supply somewhere. All right, this piece, the arm, has a little sleeve that goes down in here so that you're not rubbing a bolt on this. This is just aluminum, so it's really soft. Also, sometimes these, and it looks like this one might be one of them that is going to do that. I can't see, whoops. There should be a little washer in that gap, and I don't see one. So what's going to happen without that washer there is, as this turns, it's going to eat away at this, and eventually it will fail. That's probably another reason why I took this one off. It's because it doesn't have that washer in there. I could probably find one, but don't have one currently. Oh, I haven't put my drive on there. Let's see, I'm going to have to loosen up the set screws. Actually, this one only has one set screw. That's not ideal, except that this, I don't know if you can see, this one is a D-shaped shaft, so it has a flat spot. So I'm going to line that set screw on the flat spot. Oh wow, all right. Slight order of operation problem. I have to put that on before this goes on. Let's see if I can just... Nope, I'm going to have to remove most of it. Alright, now put that on. Go ahead and get it lined up. I don't know exactly where it's going to go, but I just want the set screw to be lined up with the flat on the extruder shaft, or the stepper shaft. Now we can put it back together. I don't know if we'll probably run out of time before I get the solid mounts done. They're pretty straightforward. There's no secrets to them though, so you just take the springs off and put the rubber pieces in. You probably will have to change your Z limit switch, where that switch is. You'll probably have to move it up and down because the bed will probably be at a new height and it won't be very adjustable at all. It'll be slightly adjustable for tilt, but you're not going to be able to raise it up and down very easily. So you have to change the location of your Z switch up or down depending on where your old bed was. Back to this. This screw, even on the old ones, this screw can be an issue if you over tighten it. It can make it where this doesn't want to pivot, and you can lock it down too tight and you'll end up with your filament not being grabbed very well by the feeder. So if you're having issues you can't figure out, you've tightened this thing up and you think you're putting as much pressure as possible on the filament, it might be that this pivot is just too tight and break it loose. This one isn't going to get too tight because it has that sleeve in there, and it does look like they've started putting sleeves in these. Some of the older ones don't have that sleeve though. Alright, now we need to put this screw in our little tension spring in there, and I've got a couple of choices it looks like on what spring to use. Getting it in there is a issue, but we'll figure it out. Oh. No. Huh. Need some tweezers. Somehow it fell down in there and I can't get it lined up to get it out of there. There we go. Alright. Alright. Now we may, so I've got this spring. These are super stiff. These are die springs for like die cutting type of machine. Or ejection springs. These are super stiff, probably overkill. I'm going to go with the spring that was already in there from previously, and we may have to, let's see how we're gonna, may have to do this as one piece. I don't think there's any real reason to go with those super stiff springs. Sometimes I use those on the bed because they are very stiff, but I've just switched to just using the solid mounts, the rubber ones. Okay. Now, that seems good. Let's make sure we tighten these. I don't know if I tightened them or not. I think I did. Nope, I didn't tighten that one. That means I may not have tightened the one that's under there. I think it'll be alright. Nothing's loose, so I think we're fine. Let's tighten this one. Oh, that one is tight. Alright. So, definitely doesn't seem like it's going anywhere. Let's see if I can find a coupler. If I can't, then I'll get one later, but you would need one of those. You can't just go without it. I have a bunch that are the wrong size. Let's see if there's a small one. Oh, there's a big one. All right. Just got to get it out of there. Save all of your parts because you never know. You know, you think you're upgrading something and you won't need these old parts, but there's a good chance you'll need one of them at some point. Oh, in fact, I have two of these. Alright, so got to put that guy in here. Now we've got to get this one off. So sometimes that can be tricky. The way that they're supposed to work, and you know, sometimes they do easy, sometimes they don't, is you push down the little plunger, so the gray plunger, you push it down and then slide it off. That one came out ridiculously easy compared to many of them that I've worked on. So that was actually really easy. Now we just press this in here. And we've got a new feeder. Now our E-steps are not right because the diameter of this thing is not the same as what the original brass one was. So that we can't just go start printing. Also, we've got this, we've got this way too low. So we need to adjust it to the right height. And got to get the set screw turned around where I can get to it. Alright, there's the set screw. And we got to get these where the gear teeth mesh. Having trouble making it move. You still have it tight. Nope, it's definitely loose now. Alright. So you want the little grooves to be lined up, and you want the teeth to be lined up. So I'm going to put this in here to kind of line up the grooves on both of them, and then tighten down the set screw. Now what that does also do, I had this knob on there, and there's nothing left of the shaft to put the knob on, so I lose that. That's fine. Okay. Now, other than the E-step situation, we've got a new feeder, or at least a new capstan for the feeder assembly. Let's see what time it is. We do have some time. Let's just as a reminder, let's see if we can get our E-steps going. So remember, the E-steps are that we want to ask for a certain amount of filament out of the feeder, or some people call this the extruder. I always think of this part, well, where are we at? This part as the extruder, because that's where the filament extrudes from, and this as the feeder, but that's just me. So we want to ask for a certain amount and get that amount. So let's see where we're at first of all. We're going to have to preheat. Most printers won't let you extrude any filament if the hot end is below 175 or so. Cut that guy off. See how much easier that fed in there? I didn't have to try and probe around to find the exact perfect line up. All right, we've got to heat up a little bit more, and then we'll ask it to give us 100 millimeters of filament. Since this is smaller diameter than this, we should get quite a bit less than 100. Let's see. Still not quite warm enough. Yeah, I think we are. All right, so I'm going to ask for 100. Actually, you know what? Just to be, well, no, I'm already into it. All right. Okay. There it goes. It is feeding filament, so that's good. Going super slow, but you don't really want it to go fast, because if you try to go too fast, then it will potentially skip. Now that we have the gears in here, though, it will be less likely. I don't know if you can see both of them turning or not, but they are. Both sides are now turning. Both sides are gripping the filament, and they're feeding it through. So hopefully, my goal with this is two things. One is just make it easier to load the filament, because this one, it was just super hard to get the filament to hit that one little hole right there. That was just hard to do. So improve that situation, but also to get a little bit more control over the filament that I'm sending out. Still going. I think I will set up our PETg vase before I mess with these. I'll probably just do these offline. There's no real secret to them, other than you probably have to adjust your Z trigger. All right, so that's what it thinks 100 millimeters is. Clearly not, but let's measure what we did get. So we got 69, 68.79 millimeters. So we asked for 100 and got 69, not nearly enough. So let's see what we should ask for. Our current E-steps are, I'm looking at the panel over here. It's this weird transmission ratio. Transmission ratio for E, 95.5. So we were 31% low. $125. Okay. Now let's auto home everything so that it, for some reason this one homes the extruder too, and that's every time you change the E-steps, so that's why I wanted to auto home it. And now we will move extruder. It's already at 100 it thinks, so we're going to go to 200 to get another 100. At least I think that's the way it's setting up. Okay, and it's going again. So I'll do this a couple of times. I don't want to do too long because I do want to go to Cura. While it's doing that, let's go over to Cura and set up our vase. This is the Vase 57 from Printables at 50% scale. So I like it. It's the one that does these little vases. We are going to prepare. We are going to use PETg. This one, I don't even see the brand name of this. It says Blue Raz, but I don't know who makes that. So we're just going to go with generic PETg. No, we're not, but there it is. We are going to keep the changes we made because they are the retraction speeds. Oh, the flow rate's low. We'll keep the changes though. Flow rate's at 100. It just wasn't updated. So to print this in spiral vase mode, I type in spiral, and I make sure that spiralize outer contours is on. This option will stay on for the next thing I print also. So if you ever do vase mode and then you go to load up something that's not vase mode, unless you uncheck this, it will try to print that thing in vase mode. So always do a preview, and if it looks really weird, there's a good chance that you left spiral vase mode on. Let's make sure 0.3, that's fine. Walls don't matter. Bottom 2 layers, infill doesn't matter. Print temperature needs to be higher. I'm going to go with 220 as a start. I haven't done a temperature tower for it, but I'm going to go to 220. Build plate, it says 70, so we're going to go to 70. Print speed, I'm going to go slower than 65. I'm going to go to 50. And it did change the fan speed to 50%. That's fine with me. Although the bag says 100%. That's not normal for PETg. So I'm going to do 50. Although I probably should. I want to do what they say. They say 100. I want to do 100. I don't know why it says that though. That looks fine. Slice 49 minutes. Check our preview. That is a vase mode, so that looks like it'll work. Let's check over here and see where we're at on our 100 millimeters. We're closer. We're at about 90. So we're still 10% short, it seems like. So let's go back, control, motion, transmission ratio. Normally that's called steps per millimeter or something. We're at 125. And we want to go up 10%. 137. Sometimes, and it might have been with this one too, the documentation for the new feeder will tell you what E-steps to use. Alright, prepare, auto home. Going to spit out some more. Move extruder to 300. Let it do. We go back to Cura. Let's save our file for printing. Got to find my adapter. We're going to get rid of this thing soon. We're going to get rid of this thing. We're going to add wireless printing. Some of your printers might by default have that. It is getting more common. Mine does not. So I'm going to add that to it. Okay, it saved it as Vase 57. Still extruding over. Yeah, still going over there. It's going slow, but it's going. I probably could have changed the feed rate to something a little faster than this, but it is working, I guess. It's just really slow. If this one's at all close, we'll just go ahead and print. I think we're getting close. All right, stopped. Let's see what we have. $99. We'll call that good enough. We could probably get slightly closer and be more careful and whatever, but I think we're good. Oh, we're going to put our PETg filament in. Now, I am using an open roll like this, which they will give you problems for sure. Oh, wow. This is mangled up a little bit, so I don't know. We'll see what happens to it. But these unspooled rolls can be a real problem. I don't have it with me right now, but I do have a roll that you can put your own filament on. I just don't have it easy to get to. But look at this. Look at those sharp corners there. That's not going to be very good. So I don't know. That might have. You know, this is just a sample, so I don't know if their whole filament is like that or not, but it's not a great thing to have. Got to put our tube on. Tube is actually being really hard to put on for some reason. There we go. I will have to find one of the little clips that goes in here to keep that from moving back and forth. I'll look for that when I can. I'm going to try and get some of the PETg to push out whatever yellow might be left in there. Oh, it's at a colder temperature now, so it's having trouble. Let's preheat for, well, let's just print. Okay. I'll leave it there where you can kind of see what it's doing. Just having to get the bed up a little bit hotter because we set it to 70. And then I set the print temperature to start with 220, which is a little bit low for normal PETg, although this card does say it can go down to 210. And I do have the 100% fan on there, which is also not normal for PETg. Just cleaning up around here while it's loading up. Right now it's heating the nozzle. That little clip, this clip back here, if you lose them, you can print them. They have printable ones on Thingiverse, which might be what I have to do because I don't see a one that size ready to go. So I might need to get one from printing it myself. Alright, it's homing. Let's check our extrusion. So it came out green because I had yellow in there. Alright, so it is extruding. It's a little bit not smooth, and it is still this green tint. Filament will do that. If you don't completely purge the old color, then they will mix for quite a while. So the bottom of this vase will probably be kind of greenish. Now it looks like it's doing okay. I will say these vases, since they're in vase mode, they don't have stringing to begin with because they never make any travel moves that aren't just printing moves. So you might get one of these vases and think you've got everything dialed in, because they'll look really nice because of the way that vase mode works. And you might still have issues with stringing and all that when you go to print some other part. So don't rely on a vase mode print to tell you you've got all your settings dialed in. Alright, so this said it was going to take 40 something minutes, 50 minutes. So I'm not going to sit here and wait for it to finish. I think we'll end here. Next time we'll look at what this did. We'll add our solid bed mounts. We will, I don't know what else we'll do. Well, we'll also print this, just because I want to see what it prints like, because it looks really cool. And then we'll add in a couple of new things. We'll keep adding new filaments, new processes, new upgrades to the printer, things that you might want to change just because you want a different, you want to do a particular thing with your printer and not what it was originally set up to do. And so we'll keep adding and changing up our printer. I will see y'all. It should be regular class time on Wednesday, so 9 o'clock Wednesday morning should be the next one.